So my plans for today are to um, answer any lingering questions on PA3, talk about how we calculate the predicted number of guesses that the program will need, which involves using logarithms base 2, and then talk about doing some string processing for deciding if the user has entered H, L, or C exactly, and then talk about Makefiles for building up our project in pieces. And then after that, probably starting tomorrow, go back and talk more about GDB. So any questions before we begin all of that?
I do have a question just pertaining to how our function returns the HL or C. You want it to actually return the string value, right? Not like decode it to like 1, -1, or whatever. It must actually come back at HL or C, right?
Yeah, it should, if that's how it's prototyped, which I think it is. Just return a single character.
Is it okay in the main program to do the logic there, or do you want a separate function to like decode what that means and what it does?
Totally up to you.
Okay.
Yeah, these are sort of the minimum required ways to break your program up, and that's probably fine. But you can definitely envision and implement other functions in separate files.
So, real quick, I do have one other question.
Yeah.
This pertains to like arguments from the command line. So I recycled a lot of code from the stick program.
Good.
For that function, and I'm curious: is there a way to pass those values to a function?
Which values? argc, argv?
Like, yeah.
Yeah. In fact, we had an ODP that did that. So you can write any old function you want and just define the arguments of that function to be an integer and a char star star. And then you can call that function with a pair of arguments in main, argc and argv, and it will pass them, and it'll look exactly in your function the way it did inside main.
Okay.
And so there was one of the ODPs, 410 or 411 maybe, that I think you made a start function. Okay, cool. All right, so let's talk about this predicting the number of guesses in PA3. So it's supposed to tell you in the beginning, hey, I will guess your answer in 5 guesses or 7 guesses or something like that. And so there's a formula you just use for that. It's basically 1 plus the logarithm base 2 of 1 plus high minus low, and it's got to be exactly this formula. Oh, cool. Thanks. ODP 412 start function. So 1 plus log base 2 of 1 plus high minus low. And we don't need to talk about why this works. And I kind of pulled it out of my head and tried it, and I added the 1 on the side because it seemed like we needed that. But it's just a formula, right? So you're starting off with your low and high. So if you're playing the game from 0 to 100, this is low, this is high. Take 1 plus high minus low, that'll be 101. Take the log base 2 of that, we'll tell you how to do that in a second, add 1. All of this will be, a real number, a float or a double. And to use it, just assign it to an integer. Don't try to truncate it, right? Just do the assignment, and it will convert it for you. And you may need to cast it as an int. But casting it will round it down, and that's exactly what you want. Yes, you are allowed to use math.h. You're pretty much required to. All right, so that's the formula. You got your high, low, you got your 1. Change this into a double, right? Because high and low are presumably integers, so make sure this is a double, pass it as an argument. to your log function, find the log base 2, add 1, and then just turn that back into an integer. So the real question here is, how do we find logarithm base 2? And there's a formula which says log base 2 of x is the natural log of x divided by the natural log of 2. That works for any base. So log, the regular log function in Unix, is logarithms base e. And
I'm supposed to, but I had to use the -lm when compiling it.
Mm-hmm.
Otherwise it didn't recognize the function.
So make sure -lm is at the end of your compile line. And
yeah, it seemed to work at that. I did a quick Google search for the problem I was having, and someone said, "Yeah, just use -lm and it'll fix it." I tried, it worked.
So some functions like printf and fgets are automatically included when you compile. Some functions like log and square root aren't included by default, and so you can use the -lm to say include the math library. And the m is the name of the math library. It's libm.a usually. Yeah, go ahead and send me an attendance note. And somebody pointed out C99 has a log2 function, so you can use log2 also. Or you can do a natural log and divide by log of 2. So, so here's just an example of that. So this is not PA3. This is just looking at calculating log base 2 by doing this business. So we're including math.h in the beginning. You want that to prototype the log function. And then here I'm just entering an x, getting an fgets, and then using an scanf with a %lf to read this number as a double. I'm printing out what it's equal to just for confirmation, and then I'll print out log x equals and print out log x over log 2. If you compile without the -lm switch, you get this message from the linker saying undefined reference to log. Right? If you get that message, you got to tell it -lm, tell it where to get the log function from. So include that library with -lm. That compiles, and now if I type in a number like 1024, it tells me what the logarithm is, base 2. So that's all there is to predicting the number of guesses, right? Just use that formula that's in the assignment. And again, calculate this using doubles, right? So cast high and low to doubles, add them, add 1, take the log, add 1 more, and then cast that as an int using parentheses int. Let's see, why is it we have to specify the compiler to include the library math-lm, but number include main.h works just fine. When you say number sign include, you're basically saying find this file and include it in my source program. And that's something that's happening at compile time when it's ingesting your .c code, right? But the -lm is saying, hey, when you're building the executable, you're going to need to use some libraries. You're going to need to use the library that contains printf, for example. Well, that one's built in. The -lm is saying you're going to need to use the library that includes math functions also. That's what -lm is saying, and it will go off and it will pull the code that's comprises log and cosine and all of that stuff. So we're going to dig into these .h files in detail presently. Well, after one more thing, we'll start talking about Makefiles, and we'll talk about .h files in detail there. Alright, so first I want to talk about some strings. And there's this requirement that as you're playing the game, the user will say if the guess that the computer made was high, low, or correct, right? And so the user will enter H, L, or C to indicate whether the computer's guess is too high, too low, or correct. And under requirements, your getAnswer function, right, should tell you if the user entered exactly an H, an L, or a C, right? Exactly a single character. Anything else, your function should print an error message and try again. So we need a way to read input from the user and know, did they type exactly H, L, or C? Or something else. And so we can do this without worrying about scanf or anything too weird. And so let's make some code for this. Let's see, PA3 is due on Friday at 8 a.m., correct? All right, so we want to know if they typed in a single character H. The thing to know about fgets is it will type whatever you type in up to and including the enter key, and it will store that in your array. So if the user types H followed by enter, and we're saving this in temp, it will look like H followed by a new line. The enter basically generates a new line. And if they type an L followed by enter, then temp would be equal to L followed by a new line, and so on. So there's a number of ways we can detect that they typed, an H, L, or C, or they typed something else. One is to look at character bracket 0 and see if it's an H, L, or C. And then look at character bracket 1 and see if it's a quote \n, a new line. And if both of those things are true, we got good input. A second option is to look at character 0 and see if it's an H, an L, or a C. And then also use the string length function and see if our input has a length of 2. If it does, we're guaranteed that this was a single character followed by a new line. It means they typed one character and they hit enter, which is what we're trying to detect. The third option is just to see if temp is equal to this string. And so that's the option I want to use here. So did the user enter exactly a single character H? I misspelled character, that's okay. So let's see if temp is the string H followed by a \n. All right, so the way we do that is to use the string compare function. So string compare is a way to compare two strings and see if they are equal or different. So if we say string compare s1, s2, this will return a number that's either positive, negative, or 0. And what it's actually doing is it's comparing these two strings to see if they're in order, to see which one comes first. If s1 comes before s2, this will return a negative number. If s1 comes after s2 alphabetically, this will return a positive number. If s1 and s2 are exactly the same, this will return 0. So for here, we don't care about ordering of things. We just want to know, is the input string exactly an h followed by a new line? So we can use string compare. So let's just run this test code, right? It's going to ask us to enter. I'm just going to look for an h. And if the person types in just the letter h followed by an enter key, it should say, good, you entered h followed by an enter key. So let's see if this works. I called it in. Oh yeah, so you need to include string.h, because that's where string comp comes from, or is prototyped in. Alright, so let's go ahead and run this, and it'll say h please. If I type in h and I hit an enter key, it says good, you entered h. If I type something other than h, it doesn't say good. If I type two h's, it doesn't accept that. If I type an h followed by a space, it doesn't accept that, right? The only time it's going to tell me that it saw an h is if I type exactly the letter h followed by an enter key. And so this is the way you can test the result of fgets, right? The string that you got, to see if the person typed an h. And if it did, then you can go ahead and do what you want to do. You can also do a string compare to see if it's an L followed by a new line, and if so, adjust your low variable. And if it's a C followed by a new line, then the game's over, and you can, congratulate the user on losing and whatever you want to do. So that's how you can deal with that requirement of making sure the user typed in HL or C. Just use a string compare. And string compare is a function we'll come back to later on and use to do more than just compare strings. But you cannot use equal equal, right? Equal equal does not work for comparing strings. So don't use equal equal for strings. So if temp equals equals, h\n will print out equal equals works. Right, but it does not work. So don't do that. I am going to do some string-based ODPs, but probably not for this. But you can write code and test your understanding of this, right? I mean, you can use this to write your getAnswer function, and then just write a main program that just keeps calling getAnswer, and printing out the return value. Yeah, so string comp is a good function to know, and it's got a manual page, of course. Basically takes two strings and compares them and returns an integer less than 0, equal to 0, or greater than 0, depending on whether S1 is less than, the same, or greater than S2. So yeah, if you're not familiar with that, write some code like this and play around with string compare. And you can definitely do this by comparing characters directly also, and it's probably slightly shorter typing wise to just see if character 0 is this, and see if the length is 2 or something like that. And yeah, that's fine. just make sure that you know it's a C without anything else after it except for the new line, because if you type extra stuff, you should notice that. Right, so that should be a problem. H followed by a space should be a problem. Space H should be a problem. Hitting enter should be a problem. It's got to be just an H. %C, %S, and a scanf will not pick up an H followed by a space. It will look at that and it'll say, yeah, this is a %C and there's nothing extra after that. But scanf ignores spaces. And so scanf is great when you want to parse things like integers. You know, if you have a string like 5, 7, 8, and you want to look at the ASCII codes and see this is a digit 5, 7, 8, and multiply by 100, multiply by 10, and add those together. That's what scanf does, right? It does all of that by just saying scanf with a %D. That's when you want to use scanf. But trying to scan to pick up an H followed by a new line will not work, right? Because the new line is white space. Scanf will basically ignore it. And so if you had a space followed by, or space following that, it won't recognize that as invalid usually. Depends how you do it. But you can check for the string length equal to 2. All right, so other questions about that? Hopefully you're developing this in pieces like we talked about last week, right? So you've got the core game playing already, assuming perfect input and maybe not predicting the number of guesses because we said we wouldn't do that till this week and so on. But if you got the core game playing, right, then you can go ahead and embellish your get answer function to start, you know, doing this kind of detailed error checking, and you can write your predict function and so on and so forth. Just double check your code and run it against the sample PA3 on the server and make sure that if you type in anything other than H followed by enter or L or C followed by enter, it should give you an error message. I don't think you can easily get scanf to do that, but if you can, perfect. Go for it.
So, real quick, so you said the string length should be 2 characters? It should be the
correct.
Plus a, okay.
Yeah. So that's always a safe check is check the first character, make sure it's H, L, or C, and then do string length to make sure it's 2. And if it is, then it's got to be the new line. You're guaranteed.
Yeah, I had it look for the null character, which worked really well, and everything was working, but then I tried L space, 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 and a bunch of characters, and it took it.
Oh, okay. Yeah, if you checked temp bracket 2 for the null character, that should also tell you, because that'll tell you the string length is either 2 or 1 or 0, and if you found the first character was this, then that's as good a check. And I mean, part of the reason that I'm giving you all of these requirements is to give you kind of an excuse / opportunity to dig into these kinds of things. So this is good. Hopefully you won't feel like you're wasting time by trying to do something one way and it doesn't work, and trying to do it another way and it doesn't work, and why can't you just tell me the way to do it, right? Because that's the learning process, right? If you do this one way and it doesn't work right, then you're learning something about that way that you did it, right? And so we end up with more than just a high-low game at the end. You end up with, you know, a deeper understanding of these tools and building blocks. All right, so let's talk about Makefiles. So let me see what I've got here. Okay, let me just do this from scratch. All right, so we're gonna make a really simple program. And my goal here is to talk about how we can take a main program and break it into functions in separate files, and then compile those and link them together, and then talk about .h files and why we want to use .h files sometimes and how we use them, and then talk about Makefiles that let us describe how these individual pieces should be combined together to make an executable program. So I'm going to generate a bunch of code fairly recklessly. And so I'm going to have a function called begin that just does some initial stuff. I'm going to call a setup function that will do something that returns an integer which I store in x, and then I'll make a display function that I pass x to and does some sort of display. Alright, so let's write our functions. So begin we'll just print a message. Our setup function will just return some number for some reason. And our display function will just display some number that we pass to it. Alright, so there's our basic main program. This is obviously not PA3, right? This is just some file that I've taken my main program and broken into basically a bunch of function calls. So call some initialization, do something to get a value x, and then display the value x. Alright, so if I compile this, I'll get a bunch of warnings because I haven't declared the prototypes for any of my functions. So I'm going to put those in the beginning here. I'm going to say begin is a void. Setup takes no arguments but returns an integer, and display returns no value but takes an integer. And so I can compile this and I can run it, and there's my begin function which said hello, here we are, and then setup returned a value of 297 and displayed it. Alright, so that's my program written as one big long monolithic file. Now imagine I had 100,000 functions, and these functions were 50 lines of code each. This thing would be a huge file, and to do this would take, maybe a few hours. And so let's say I want to display a different message. I want to say greetings. Okay, I've changed part of one line of my file, but if I do this, I've got to recompile all of my functions, right? 1,000,000 lines of code could take a few hours. So the first thing we want to do is we want to break our function, or break our program into separate files. I misspelled separate. That's okay. So how do we do this? I'm going to make a begin.c. A setup.c. and a display.c. So my main is just going to have my main program. My begin just going to have my begin function, my display, will look like that, my main is good, and my setup will look like this. Alright, so what have I got? I've got 4.c files, and I've got my main program. So if I want to compile all of these things, I can compile each of my .c's. I can say make the output program main, and if I say main, there's my output. And let's say I want to change my setup function, so that instead of returning 297, it returns 42. Well, I make that change, I recompile everything, my program runs and displays the new magic number. Alright, so I've got things broken up in pieces, which is nice because, you know, these are smaller things to work with. This is just my program, my function that prints out a greeting. This is just something that displays a number. This is just my main program, which is just a bunch of function calls. But when I'm compiling it, if I just compile all of my .c files, that's expensive. So what we'd like to do is a more sort of a more nuanced compilation stream. So here's what we can do. Suppose we have, you know, file 1.c, file 2.c, file 3.c. And our goal is to compile all of these together into something called main, right? This is executable. These are source files. If I just say gcc all of the stuff.c, these just turn into my main program, but each of these is being recompiled. So what I can do is I compile these files individually into what are called object files. .o files. So these are object files. And then I can link all of these together into our main program. So to build the object files, I use a -c switch on GCC. And if I don't use a -c switch, then I can compile these, I can link these objects together into an executable. Alright, so let's do this in practice. I can say gcc-c display.c and setup and main and begin. And now I've got a .o file to go along with each of my .c files. And to build my executable, I can do the following. I can just say, take my .o files, turn those into an executable, and run my main program. Alright, now suppose I want to change my setup function. So I edit setup.c, and instead of doing 42, I want to do 999. I don't have to recompile all of my .c files. All I have to do is recompile my setup.c and then do this, which links my .o files. The advantage is I did not recompile main.c, I did not recompile display.o, I did not recompile begin.c, right? These source files did not change, and so the object files that I already have are perfectly fine. But setup.o, that's the old object file. That was with the old number 42. I changed my number in my source code. I need to rebuild setup.o, so I said recompile setup.c. But now linking these .o files together, that's a really efficient operation. And so I've got a completely rebuilt program that I got by only recompiling the piece of the code that I changed. And that's what we want. If we're building a big project that has, you know, 10,000 .c files, and we change one of those files, we don't want to recompile 10,000 files. So what we do is we compile with this C switch, which changes these source files into these object files. Right? It does this first part of the compilation and we stop it right here. And then if we change file 2, we can just recompile that into a new file 2.0 and then link those together into our executable. Practically speaking, this makes no difference to the projects we're doing in this course because the projects are small enough, they compile, you know, in the blink of an eye. But thinking in terms of working on a larger project, working with other people, collaboration, and so on, this is one way that we can do this in Linux, is compile your source code to objects, these .o files, and then link your objects together to get your executable. All right, questions up to that point? So let's talk about .h files. If we look in main.c, you notice I've got prototypes for functions in here. I'm defining the prototype for begin, setup, and display, and I'm also including standard io.h. And it turns out this is the only program that needs to use these other functions, so it's the only file that needs to have these prototypes. But on a larger project, typically, you know, you might have a getAnswer function that's being used by a half dozen different .c files. And you might have a setup function that's being used by 100 different .c files. And so anywhere that this setup function is being used, we need to prototype it. And so inside that function that's calling setup, I'd need to go in and I'd need to put in this prototype. And you end up typing in these lines of code again and again and again. And the real issue is if something changes, if I decide setup's going to return a long integer instead of just an int, I need to find everywhere that I prototyped it with an int and change that to say long int. So we're going to do something different. We're going to take these and we're going to put them in a separate file, which I'm going to call main.h. And then inside main.c, instead of typing in all that stuff, I'm going to say include quote main.h. And that says look in my current directory for a file called main.h. And if you find it, take the lines in that file and basically pop them in right here.
The top of your editor's a little high.
Sorry?
You can't see like the include main quote h or include
How's that?
quote main.h.
Is that better? Okay.
Yep.
Weird. Okay, thanks. So these 4 lines of text will basically replace this include statement. And before my code actually starts to get compiled, it goes through what's called a preprocessor. And one of the things the preprocessor does, it says, hey, here's a number sign include. Let's look at main.h. There's 4 lines. Okay, I'm going to take those 4 lines. I'm going to put them right here. And when the compiler starts running, instead of seeing number sign include, it's going to see these 4 lines. And instead of seeing include standard io.h, it's going to see like 1,000 lines, which are the contents of standard io.h. So includes really just sort of open a file, pull that stuff in. This is what I did for my PA3. Is this okay if we did it this way for our functions and libraries? Sure, absolutely. Yeah, that sounds perfect.
So why is it quotes instead of brackets?
So if you have something in angle brackets, it's going to look in a special directory /user/include. And so like standard io.h, we don't want to have to constantly say include /usr/include /standard io.h. So the angle brackets say this is a system include file, look in a set of predefined directories. Quotation marks say look in my current directory. And since we're writing this ourselves, it's going to be in our current directory. So that's what the quotes do. All right, so what I can do is actually I can just include main.h in all of these .c files. right? And since main.h includes standard.io.h, by including main.h, I'll automatically be including standard.io.h. I'll also be including function prototypes. Now, if I don't use that function prototype, for example, inside begin.c, I'm prototyping my setup function, I don't use it. That's not a problem, right? Inside my setup function, I don't do any inputs or outputs. I don't do prints and gets. I'm still including standard.io.h. That's not a problem, right? What you want to put in your main.h file is function prototypes, maybe other includes that you want to do. If you're using structures, you can put structure definitions in there and so on. All right, so now I can say GCC well, I don't know where I want to do this. I'll just do star.c and be lazy, right? So that builds everything up. All right. So that's good, but you know, my hesitation here was, what do I have to compile in order to build my executable program? And if, for example, I change a function prototype, what .c files do I have to recompile? And so this is where Makefiles come in. And a Makefile is a way to describe basically a set of instructions for building an executable. And we are going to run out of time before I get through that. But if you catch the last 13 minutes of the previous section's video, that's where I talk about Makefiles in there. But a Makefile, yeah, it's kind of like a specialized bash script. It's basically a file that consists of pairs of lines. And so the first line has what we call a target, followed by a colon, followed by a list of what we call dependencies. And the second line begins with a tab. It has to be a tab, can't be spaces, followed by a command. And if I put a series of lines in a file called Makefile that look like this, then I can use the command make. And if I say make target, and there's a line which has a target with that same name, it will basically use this command to build that thing. And it will let me specify things that target depends on, files that need to be up to date in order to build an up-to-date version of this target. So I'm not going to rush through this in 65 seconds, but take a look at the video, the last like 13 minutes of the video from the 10 o'clock class, and then ask questions about this tomorrow. And there's a sample of this up on the shared code area on the Linux server. So go under 224 and go under Makefile stuff. And there's a sample Makefile in here, along with some sample programs similar to what we've been doing. I call them get, answer, intro, and display. But there's a sample Makefile. So take a look at the video, take a look at the shared area, and ask questions about this. We can talk about it more tomorrow. And then my general plan for tomorrow is to go back to talking about GDB. And get through some more of that, and then we'll start talking more about Linux after that. All right, send me an attendance note, please, on the way out. Let me know you're here, and that should do us for today. Have a great afternoon, and I will see you tomorrow.
Thank you.